Hi, today we'll be learning about graphing linear inequalities in two variables. This lesson is actually going to be two parts. The first part is just learning about inequalities or refreshing your memories about inequalities and graphing them on a number line. And then we're going to use that information to graph them on a plane. So first of all, remembering what these inequalities mean. This first symbol is the greater than symbol. And with the addition of the bar below it, that would be the greater than or equal to symbol. So then this would be the less than and less than or equal to. So remembering that an inequality, not an equation, means that there's no equal sign there. These are the symbols that you'll see instead. So to solve a linear inequality, treat the inequality as an equality and then solve it algebraically. There's really two catches. That when you multiply or divide by a negative number, the inequality sign will actually flip. So don't forget to do that. Often we're going through really excited about finishing the algebra, and we'll sometimes forget to flip that inequality, and when you do that, your statement is no longer true. Also be sure to graph the solution set on a number line, so that's the second piece. So if we're graphing them on a number line versus graphing them on a plane, and we'll look and see when we do one or the other. Also, when you're solving, you don't have one value as your final solution, but you have a whole set of possible solutions. So we call this the solution set. Let's have a look at this a little bit further with a couple of examples. So if you look at this first example, this would read x is greater than or equal to 3. X is greater than or equal to 3. So that means the solution set for this could be 3, because the or equal to 3. Or it could be 4 or 5 or 6, or it could even be 3.1, 1,000, 1,002, 0.456, like any value greater than or equal to 3. Now, we can draw this on a number line. When you do that, sometimes you'll be given a number line, you can just plot it on there, or we can just draw it right here. We could put 3 on our number line, and we can state that it could be greater than or equal to. And recall that I'm filling in a dot here because 3 is included in the solution set. And then the arrow to the right indicates that any value to infinity greater than 3 is part of the solution set. Taking a look at example B, this reads x is less than 3. If I draw the number line for that, 3 is plotted in the same place, but now less than 3, my arrow is going in this direction, and notice also I left an open dot. Open dot means that 3 is not included. There's no or equal sign there. That symbol is not there. So for greater than or less than, we use an open dot because it's not included. It is in the number. Whereas if you have a greater than or equal to, less than or equal to symbol, you have a filled in dot because the value is included. Now, if you look at B, this is sometimes when you solve it, sometimes stated as 3 is greater than x, and that means the exact same thing. You can read this from left to right, or you can read it from right to left. I would always start with the variable and read it in that direction. So if we're reading this from right to left, it still says x is less than 3, and this statement is still true. If this bothers you to see it in this way, just flip it around. Just make sure you take the inequality with it and flip that as well. Okay, so that's when you get your solution. But how do we get to that solution? If you look at C and D, we're going to be doing algebra here. We're going to rearrange and solve using the same algebra techniques that you've learned in previous years. So if we look at C, I can see that I can isolate x by removing the 3 or doing the opposite operation. Now, we see that minus there, so it's tempting to write a plus 3, but you're really looking at the sign in front of the 3, and in front of the 3 you have a little plus there. So opposite operation is create a 0 pair here. That would be subtract 3. Whatever I do to one side, I do to the other side. So that cancels out, and I'm left with negative x is less than 5, subtract 3. Looks like I've isolated x, but there's still that negative sign there. In order to get rid of that, I'm going to divide through by negative 1. You can do it like that, or sometimes when we've got the two values there, I like to do it like this. Really what we should have done, though, is simplified 5 minus 3. And 5 minus 3 is 2. Divided by negative 1. That's a lot easier there. So, divide both sides by negative 1. I'm left with a positive x here is less than negative 2. And at this point you should be yelling at me because I did not flip the inequality. Why do I need to flip the inequality? Because I divided both sides by a negative 1. So change that inequality symbol, so now it's a greater than. So x is greater than negative 2. Once you finish that, plot it on a number line, negative 2, open dot, and greater than. Have a look at D. The exact same thing, except I can see there's a couple extra steps in order to get x isolated. I've got x in 2 places, but I also have all these brackets, which remind me that I need to distribute. The word distribute just means to multiply everything within the set of brackets. So 3 times x, 3 times 5. Less than or equal to. I've got negative 4, and distribute that to the 4, and then negative 2x. So that would give me a negative 16 plus 8x. Looking at this, I'm going to get my x's together. So I'm going to subtract 8x from both sides, creating a 0 pair there. Use of color might help here. So subtract 8x from this side, subtract 8x from this side. So there's my 0 pair, that's gone. 3x minus 8x gives me a negative 5x plus 15, rewriting the rest of this, less than or equal to negative 16. Now I've got the x's together on one side, and I can get rid of that 15, move it to the other side by doing the opposite operation again. So subtract 15, that gives me a 0 pair, do the same thing to this side. We've got negative 5x is less than or equal to negative 31. At this point, I only have one final step to take, and that would be to get rid of the negative 5x, well, not the x, but the negative 5. Opposite operation here would be to divide by a negative 5 from both sides. That gives me a 1x, which is what I want, that x isolated. And then the two negatives cancel out, but I'm going to leave it as 31 over 5 because that doesn't simplify nicely. And remembering that we need to flip the inequality. Why? Because I divided both sides by a negative sign. Had I not done that, if I just divided both sides by 5, if that was a positive, I could leave the inequality symbol the way it is. So let's draw this on the number line and just draw it as 31 over 5. You can change it to a decimal, you can change it to a mixed fraction, but you don't need to, and if you make a mistake while doing your simplifying, then we do get a half mark taken off. So it's usually in your best interest to leave it like that. Your calculator understands it, I understand it. Unless it's going to make life easier, leave it the way it is. So 31 over 5, greater than or equal to, so that's a filled in dot, and an arrow to the right. Have a look at the next page. Last part of this half of the lesson, just to make sure we fully understand what these inequalities mean, is to explore here. It says, for which inequalities is the ordered pair 3, 1, remembering that that's your x and y, a possible solution? How do you know? Good question. How do we know? So we're using substitution here. Remember, when you use substitution, you use brackets. So I would have 13 minus 3. The x value is 3. Using brackets here, greater than 4. Y value is 1. Now, when you're doing a check or a test, you never rearrange the inequality or equation. If you're testing an equation, you leave everything on the left side on the left and the right side on the right. And you just evaluate and you test, you check, you ask yourself, is this statement actually true? So we would have 13 minus 9 is greater than 4. 13 minus 9 gives us 4. And our final statement here is 4 greater than 4. And 4 is not greater than 4. 4 is equal to 4. So this would not be true. So we could say that this is not a valid statement. Not a possible solution. Let's try B. Y is 1. X is 3. 1 plus 3 gives me 4. Is 4 less than 10? Sorry, that looks like a 16 there. 4 is less than 10, so 3, 1 is a solution. Valid solution. Now at this point you might want to just pause the video, try C and D on your own, and then check with us. We've got 2 times 1 minus 5. Is that less than or equal to 3? That would be 2 minus 5, or negative 3. And negative 3 is less than or equal to 3. It's a valid solution. And then our last one here is 1 greater than 9. No, it is not. So that's not valid. Okay, thanks for joining me today. We're going to stop the lesson here, and in the next part we will look at how to take these inequalities and graph them on a plane. Thanks again.